Hello everyone, welcome to today's session on Remainder Theorem, Polynomials Class 9. In this session, I will explain you Remainder Theorem using one example. I will also show you how to solve the question example by using the long division method as well as Remainder Theorem. You can compare both the methods in this and so that you can understand which one is easier or better to use in exams. So stay with me till the end. Quick recap, like algebraic expressions. Here I have written examples of algebraic expressions, and you are already aware that algebraic expressions are the expressions which are a combination of constants, variables connected by the mathematical operations. So two examples I have written in algebraic expressions. Now let's check. These are also algebraic expressions. So we need to check whether these algebraic expressions are polynomials. What is the extra condition for polynomial? That the algebraic expressions, any algebraic expression whose variables are whole numbers, so they are called polynomials. Okay, they should be non-negative integral power, it should have. So like first example, this is an algebraic expression. It's a polynomial, right? Why? Because the power of the variables are all whole numbers, are all non-negative powers. So this is a polynomial. In the second case, this is not a polynomial because in this the variable power is fraction. It's not a whole number. So we cannot say it's a polynomial. The condition of the polynomial is not applied here. It's not fulfilled. So let's see the third example. In this expression, here also in this term, the power of the variable is negative. So that's why it's not a polynomial. Okay, so let's come to our topic, that is remainder theorem. So you know that students, whenever you are dividing two numbers, you are getting, like for example here I'm writing, suppose 14 is divisible by 7, what you're getting? Quotient 2. Simple example. This is like a whole numbers you have taken, but now instead of whole numbers, the same concept is applied in polynomials. So px is one polynomial. When it is divisible by the divisor, which is another polynomial, then what you're getting, you can easily find the remainder, and remainder is p of a. So how will you find this? There is a simple trick that whatever the divisor is there, you just make it equal to 0. Okay, and solve for x. So x is equal to this minus a will transpose this side, this you are getting. So substitute this value of x, that is a, here in the polynomial, and you are getting that is your remainder. Okay, let's look here. Here the linear polynomial is different, right? Why it's linear? Because this divisor is always less than the degree of the divisor should be less than the degree of the polynomial, which dividend which you are taking. So here also, suppose this is ax plus b, you make it equal to 0 first. Okay, and this is your dividend polynomial. So ax plus b is equal to 0. Find for x by transposing, and you are getting x is equal to minus b upon a. And this value of x, you are substituting in the polynomial px, that is your remainder. I hope it's clear. So you can better understand. I will give you one example also. So let's look at the example. This is a question. So I have written for you. Let's solve this. First, I will solve it by applying remainder theorem. Question is coming like this. Find the remainder when x cube plus 3x square plus 3x plus 1 is divided by this. So this is our dividend, and this is px according to definition, right? And this is divided by x minus a, right? So what was our remainder theorem? Remainder, according to remainder theorem, remainder should be p of a. Okay, how I will get a from here? Either you write it in this form, x, see you can write x minus of minus 1. So I have written say minus minus plus. So you can write, so a is nothing but minus 1. But why to do that? Simply you can do, you make this equal to 0. You will get minus 1. X plus 1 is equal to 0, and find x, that is minus 1. This is your a. Okay, and remainder is, always make this linear divisor polynomial 0, find the value of x and substitute in the polynomial. That is p, instead of x I am writing -1, and this is equal to, substitute in this, -1 cube plus 3 of -1 square plus 3 of -1 plus 1. So you know that negative to the odd number of times it's multiplying. So that is -1 only, plus 3 into 1, 3, plus minus minus 3 plus 1. Easily you can cut, you can solve by any way, and these also will cut, you can get 0, right? So remainder is 0. What is the remainder coming out to be here? 0. Okay, and let's do, and when remainder is 0, there is another property, factor theorem, that will be the next video, that you will understand factor theorem only if you have understood the remainder theorem. So here in this example, you have calculated the remainder whenever you are dividing two polynomials, and remainder is coming out here as 0. And let's solve the same example. We'll solve using long division method. So using long division method also you can solve. So let's do it, and you can check it that remainder will come out to be 0, but that will be little lengthy. So let's write our dividend and divisor was x plus 1, and the dividend was x cube plus 3x square plus 3x plus 1. Now this px is divided by this, so divisor is always outside. Let's divide. You have learned how to divide the polynomials, okay, in 8th class. So let's do which number. Still I will briefly tell you. If you have a doubt, you can tell me. I'll make a separate video on how to do division, okay, long division method for the polynomials. Let's do x will multiply by what number or what variable, so that I will get x cube as it is. So I'll multiply by, see, this multiplied by x square is the first term of the quotient. Multiply this whole by this, x into x square, you're getting x cube plus 1 into x square, x square. Now you know that you need to subtract it. Whenever you are subtracting, the sign of this subtrahend will change. Earlier it was plus only, right? Nothing is there plus. So minus, this is also minus. So this will cut, it will be 0, right? And 3 minus 1, we'll ignore these signs. 3 minus 1 is 2. 2x square. As it is, you can take down the other terms, this one. Now I have to cancel this term, first term out. So again we have the divisor, which number I'll multiply so that I should get 2x square. So x is already there. X multiplied by what? That I should get 2x square. So 2x. So next quotient term I'll get plus, and this is a positive only. Okay. So 2x I'll do. Now multiply the whole x plus 1 with 2x. So what you're getting? 2x square plus 2x. Subtract again. This one earlier it was positive only, it's minus minus. This will cancel out, and 3 minus 2, 1x. That is x only, you can write plus 1. Now x plus 1 times what? That you are getting same only, it's same. First term easily you can getting if you are multiplying it with 1. So x into 1, x plus 1 into 1, 1. Subtract again this, you are getting 0. So here also our remainder is 0. And when we have used the applied, see this one, when I have applied here remainder theorem, you can write here, okay. When I have applied here remainder theorem, we have used remainder theorem in this, and then we have solved. So which one is better, students? When they are asking in the question only remainder, are they asking a quotient? No, they are not asking find the quotient or the remainder, they are just asking you remainder. So use a remainder theorem. Simply you have to make this equal to 0, find the value of x, and then substitute in this. That is your remainder. Okay, why to solve the long division method? This is a long process where you are finding any mistake, any sign mistake or calculation mistake, so you will, it is a long calculation, you'll end up then with scoring less marks. So always see, you can easily compare that which method is better. So this is our remainder theorem, and this from remainder theorem only factor theorem has been come out. So I will explain you in the next video what is a factor theorem. Till that, you all have to practice, and any doubt you can write in the comment section. Thank you very much, students. Have a good day.